This is my last video on CHUMP. The 4-bit homebrew computer is finally done. As I will demonstrate in a little bit, it's executing a basic while loop. So what should it be doing, right? What's the code do? If all works out, the first instruction should load 15 into the accumulator register. This register will hold on to the data and let us do what we want with it. We should see all the accumulator LEDs turn on. The next instruction will subtract 1 from the accumulator. This means that all the LEDs but the leftmost LED will be on. The next instruction will check if the accumulator is 0, and if it is 0, then it will jump to the 5th instruction at address 4. Currently, the code that I just said is useless, as it will only ever be 14, not 0. But if we put a go to after the if 0 instruction, it will loop back to instruction 2, address 1 on the program counter, and it will subtract 1 again and check again if it's 0, and if it's not 0, it will loop back again and subtract again. Here, I'm going to try and stop it right as the accumulator is 0. As you can see, we are at instruction 4, which means the if0 function detected that our accumulator was 0 and jumped us to address 4. Address 4 is the add function, so next we will be adding 1 to the accumulator on the next clock cycle. The next instruction is the store 2 instruction. This instruction will store the accumulator value, which is 1, into address 1 in RAM. I have no convenient way of showing you storing to RAM, but I can show you the individual values on the multimeter, starting with write enable. Here you can see write enable is 0. Next is A0, which you can see is 1, and A1, which you can see is 0, A2, which is 0, and A3, which is also 0. The last pin is the data pin on the RAM, the input data pin to be specific. As you can see, it's 1. And that is my cheap, homebrew, understandable, minimal processor.